Hello everyone. In our last video, we introduced the concept of factoring and also learned how to find the greatest common factor and how to factor out the greatest common factor from a group of terms. In this video, we're going to learn a new factoring technique having to do with expressions of this form, ax squared plus bx plus c, which are called quadratic trinomials because we have a square term, a first degree term, and a 0 degree term. Now, we're going to start out in this video with the simplest case of these, where the lead coefficient, the coefficient of the highest degree term is called the lead coefficient, a, is 1. Remember that factoring is the process of writing an expression such as this one down here, x squared plus 5x plus 6, as a product of two other factors. Now, it's easier if we actually go in the more familiar way of multiplying before we try to go in the backward direction of factoring. So just consider x plus 2 times x plus 3. You notice that we end up with x squared. If we just use FOIL, that's first times first, then the outer is 3x, the inner product is 2x, and 2 times 3 is the last times last. The L part gives us 6. So if we combine all these, we get like terms in the middle, the two like terms in the middle, we get x squared plus, notice we can factor out the x here, so we get 3 plus 2x times plus 6. So we get x squared plus 5x plus 6. So we notice that in order to go backwards and try to factor this, we would want two expressions here whose product gives us the first term. We would want two products in the last positions whose product gives us the last term. And also we want a coefficient here, which basically when we add the outer product and the inner product will help us obtain that coefficient for the middle term. So one way of approaching this is by making what we call the big X, and we notice that we're going to be looking for two numbers whose product is 6, this last number, but we notice that their sum also needs to be the coefficient of that middle term. So we want two numbers whose product is positive 6, but whose sum is positive 5, which is the coefficient of the middle term. The x term we also refer to as the middle term. And of course, the two numbers that will get the magic done are positive 2 and positive 3. So we go ahead and factor the expression as x plus 2 times x plus 3. Now, when we go in this direction, that's called multiplying. When we take this expression and write it as this product, that's called factoring. And let's look at a few more of these till we become real comfortable with these. It's extremely important in any factoring problem to notice that firstly, you're always going to be factoring completely. So sometimes we do one level of factoring and there's more that can be done. So we need to go until there's no more factoring possible. Also, what we want to always look for is a greatest common factor from the terms that are available, which is not 1. That's what I mean here by non-1 GCF. And if it exists, factor it out. If the GCF is 1, we don't need to factor it out, we proceed. And the cross diagram that we looked at in the previous set should only be used if the leading coefficient a is 1. It will not work if the lead coefficient is not 1. So since the lead coefficient, the GCF here, you notice, is 1. And the lead coefficient a is also 1. So because the lead coefficient is 1, we can go ahead and use the cross diagram. We're looking for two numbers whose product is this last term. Make sure you take the sign with it. So positive 4. And whose sum is the coefficient of the middle term without the x, just the coefficient. So positive 5. So now we want to look for two such numbers. We want the product to be 4 and the sum of the two numbers to be 5. So this is what makes these a little bit interesting compared to previous experiences you may have had, because you have to satisfy two conditions simultaneously. So of course, you know, one possible case is 2 and 2 to get 4, but notice if you add 2 and 2, you don't get 5. So, but if you think of all the factorizations of 4, 2 times 2 is not the only factorization of 4. We also have 1 times 4, and that will get the job done. So positive 1 and positive 4 should be the choices we make. Notice their product, when you multiply them, you get positive 4. Their sum, when you add them, you get positive 5. So those are our numbers. So we write x squared plus 5x plus 4. We factor it as x plus 1 times x plus 4. And it's easy to check to make sure you've done it correctly. You can just quickly multiply x plus 1 by x plus 4. Notice you get x squared plus 4x plus x plus 4. These combine to give us the 5x, so we've done it correctly. All right, so that's how we're going to be factoring these simple types of quadratic trinomials. Let's go ahead and try this one. Definitely try it on your own first. Look for a non-1 GCF. If it exists, write it here. We're going to factor it out in a minute. And use the cross diagram only if the a in this expression is 1. Of course, here we use x generally. Whatever variable you're dealing with is fine as well. All right, so here we notice the GCF is 1. Hopefully you've come back after trying it on your own. And also a is 1. So that means we can use the cross diagram. We're looking for two numbers whose product is positive 18 and whose sum is the coefficient of the middle term, which is positive 9. So we notice here that we get, if we break down 18, we get 2, 9, 3, 3, 3, 1, right? The process of prime factorization. So you can see some of the factorizations of 18. For example, of course, there's the trivial factorization, 1 times 18. Then we have like 2 times the rest, which is 2 times 9. Of course, we can have 3 times 6, right? And as we see, the one that's very helpful in this case, the numbers whose product is 18, but whose sum is 9. When you look at these, there's only one pair that seems to make the cut, and that's right here. So we're going to use positive 3 and positive 6. So we're going to factor y squared plus 9y plus 18 as y plus 3 times y plus 6. The very least amount of checking you should do is what we call the FOIL check. So you always want to make sure, even if you do this just in your head, you should always do it. You want to make sure that the first term times the first term gives you the first term. You want to make sure that the last term times the last term gives you the last term, and also that the inner product, which in this case is positive 3y, and the outer product, which is positive 6y, they combine to give you the middle term. As long as you have checked those three items, your factorization will be correct. So that's the minimum amount of checking you should do, and it can be done very quickly, mostly in your head. I would just write the inner and outer product part out so that we don't make a mistake. But notice first times first is first. That's a very quick check. Last times last is last. That's a quick check. The inner product, positive 3y. The outer product, positive 6y. They add up to the middle term. You do that, you're always going to get these right. All right, let's try another one. All right, so try this one. Pause the video, try it, and come back. Pay attention to the signs, okay? All right, so welcome back. We noticed that the GCF of those three terms, the greatest common factor, is indeed nothing other than 1. And the lead coefficient is also 1. All right, so we can go ahead and use the big cross to find our numbers. We want two numbers whose product is positive 21 and whose sum is the coefficient of the middle term, which is negative 10. So if we do a factorization of 21, that will help us find those numbers very easily. Notice 21, 3, 7, 7, 1. So basically, the ways to get 21 are 1 times 21 or 3 times 7. There aren't a whole lot of ways, right? So now we notice that of these two factorizations, the one that's most promising is the 3 and the 7, right? But notice we want the product to be positive, but the sum to be negative. How can that happen for two numbers? Think about this for a minute. How can two numbers have a product that's positive, but have a sum that's negative? The only way that can happen is if they are both, did you guess it? Exactly, if they're both negative. So basically we're going to use negative 7 and negative 3. I make a habit of putting these in ascending order. First the smaller, then the larger. That way there's some level of consistency, but it makes no difference. You could have put negative 3 here and negative 7 there. But just so that I'm consistent when I'm trying to teach you, I usually will go in small and large, like that. All right. So we're going to factor it now as, so we're going to claim that x squared minus 10x plus 21 equals x minus 7 times x minus 3. Now we'll do our quick check. First times first is first, check. Last times last, pay attention to the signs, is going to be last. Yes, that works. Negative 7 times negative 3 is positive 21. The inner product right here is negative 7x, and the outer product is negative 3x, and they combine to give us negative 10x, which is the middle term. Now, you could have done this a little bit more quickly, but I'm showing you this way because this is going to help us transition into the situation where the lead coefficient is not 1 very quickly and efficiently. So that's why I want you to get used to this 3-step check from this section already. All right, let's try another one. So try this one on your own and make sure that you are watching the signs, okay? And don't forget the 2 checks you have to do before every problem. All right, we notice that the GCF is indeed just 1 and the lead coefficient is 1. Because the lead coefficient is 1, we can use the cross diagram looking for two numbers whose product is negative 30 and whose sum is positive. What is the coefficient of u? Can you see? When nothing is written, there's that invisible 1. So positive 1. So we want two numbers that have a product of negative 30 and a sum of positive 1. All right, again, prime factorization of 30 will help us with that quest. So start with 2. 30 divided by 2 is 15. Then 3 goes into it 5 times, and 5 goes into 5 once. So On the left here, we have the prime factorization of 30, which makes it very easy to find the factors that we can multiply. So notice some of the ways of getting 30 are like 1 times 30, or 2 times that, which is 15, or 6 times 5, we can write it as 5 times 6, or let's just go with 3 first, 3 times that, which is 3 times 10. Notice you can have 5 times 6, right? So basically we need to find two numbers whose product is negative 30, and they should be pretty close to each other, because when we add them we want to get 1. And also notice the negative will enable us to play with the signs a little. So if you notice here, the only two factors that are within 1 of each other are this one, 5 and 6. So the question is, how do you multiply two numbers and get a negative answer, but add them and get a positive answer? Well, the answer really comes from here mainly, because the only way you can multiply two numbers and get a negative number is if they have opposite signs, right? So one is going to be negative, one is going to be positive, right? We know that. And the question is, which of these should be negative and which one should be positive? Well, it depends. What sign are you trying to accomplish when you add them, right? Or are you trying to get when you add the two numbers, when you combine them? You're trying to get a positive sign. So that means you're going to make the larger number positive and the smaller one negative. So the 6 is going to become positive, the 5 is going to be the negative. Because now watch. When you multiply these two, negative 5 times positive 6, you get negative 30 as desired. And when you combine them, when you add them, what do you get? Well, negative 5 plus 6, that's positive 1. So that's exactly also what we wanted. So we have found our magic numbers, and we're going to factor u squared plus u minus 30 as u minus 5 times u plus 6. And we are always, whenever we factor trinomials, we're always going to do our 3 checks, right? First times first is first, which is last times last is last. Negative 5 times positive 6 is in fact negative 30. And the inner product, which is negative 5u, and the outer product, which is positive 6u, they should add up to the middle term. Here we get positive u, which is in fact the middle term. Okay, so make sure that you do all 3 of those checks. If you ignore any one of them, it could be a wrong factorization. So always do these checks before you decide that you have the correct factorization. All right, so why don't you try this one before you come back to the video. Okay, so we have always been looking for a GCF other than 1 to factor out. We haven't had much luck until this one, right? We notice there is a GCF of 3. And also notice as it stands, A is also 3. So we have a GCF of 3 and A is also 3. When this happens, that means there is some hope that we may still be able to use the cross diagram, because as long as if the A doesn't change from 3, we won't be able to use that nice cross diagram. But right now, because we have a GCF other than 1, we're going to go ahead and factor it out. And when we do, we're left with x squared minus 2x minus 15. Now, if you bring your attention to this part within the parentheses, you'll see that in that part, the GCF is indeed 1 and A is 1. So that means for this new trinomial within the parentheses, we can use the cross diagram. we're looking for two numbers whose product is negative 15 and whose sum is negative 2. Eventually, you're going to get so good at these that you won't need to do the prime factorization. But in case you're not there yet, I'll show it. So 3, 5, 5, 1. So some of the ways we can get 15 are 1 times 15 and 3 times 5. We notice that the product has to be negative, so we know the signs are going to be different. We're going to have a negative and a positive number. And they somehow need to be within 2 of each other, because when we combine them, we need to get negative 2. So the only pair that's going to fit the bill is right there. So the only question remaining is which one should be negative and which one should be positive. Notice that this time we want them to combine to give us a negative result. So the larger of the two is going to have a negative sign on it. So that means the 5 will be negative and the smaller will be positive. Now note, when you multiply those two, you get negative 15. When you combine them, you get negative 2. So we have the right pair, and we're ready to go ahead and go on with our factorization. So we have 3 times x minus 5 times x plus 3. Notice this 3 has to continuously get carried. If you drop this 3 and just type this in as the answer, you will have had the wrong answer. Because remember, after you multiply everything out, you should get back to this. If you drop the 3 and just multiply that out, you won't get back to this, so it won't be the correct factorization. So make sure you have the 3. We can do a quick check to see whether we factored that trinomial quickly. First times first is first, last times last is last. The inner product is negative 5x. The outer product is positive 3x. They add up to negative 2x. So that right there should work out for us. Okay. So there is the factorization with a GCF on the outside. That we were able to factor out first. Here's an example involving two variables. It's handled in very much the same way. We notice that GCF is in fact 1. These three terms don't have anything other than 1 in common, and A is also 1. So in fact, we could use the cross diagram, looking for two numbers whose product, or actually we should say two expressions here, whose product is negative 4y squared and whose sum. Now, if we're going to treat this as a quadratic in x, then we're going to treat the y like a constant, right? So what is the coefficient of the middle term? If x is the variable, what's left? Negative 3y. You get it? It depends on how you view the problem. So we want the sum to be negative 3y. So notice the only way you can get that is, since you want a negative product, is if they have opposite signs, negative and positive. Now, which one should be negative and which one should be positive? Well, what do you now think the numbers are anyway? We don't want 2 and 2 because that's not going to give us 3. So we're going to pick 1 and 4, right? We're going to break up 4 as 1 times 4. And since we want a negative sum, we're going to make the larger 4 negative. So negative 4y and positive 1y, right? Now notice, look, multiply them, what do you get? You get negative 4y squared. Add them, what do you get? Negative 3y. So we have the factorization. So x squared minus 3xy minus 4y squared can be factored as x minus 4y times x plus, we don't need to write the 1, we just write x plus y. We do the quick check. First times first is first. Last times last, pay attention to the signs, is last. Negative 4y times positive y is indeed negative 4y squared. Inner product is negative 4xy. Outer product is positive xy. they add up to negative 3xy, which is the middle term, and that's what we wanted. Always do the 3-step check, otherwise you'll get yourself in trouble. All right, here's a good one for you to try before you come back to the video. Don't forget to take out any GCF, and in the first phase you're not going to really worry about a because this is not a quadratic. We're really concerned with quadratic, so go ahead and take out the GCF before you worry about any a. Okay, so what is the GCF of these three? If you've already tried it, you should have, and remember, when the lead coefficient is negative, we usually take out the negative with it, so we're going to use negative 4x cubed for our GCF. So we're going to write the problem down: negative 4x to the 5 plus 28x to the 4 minus 48x cubed. We start by factoring out the GCF. In any problem where there is a non-1 GCF, we factor it out first. It makes the rest of the procedure much simpler. So what's left? What do you multiply negative 4x cubed by to get negative 4x to the 5? Just divide, and you realize it needs to be x squared, right? And what is the second term divided by the common factor? GCF. Well, positive divided by negative will give us negative. 28 divided by 4 is 7. X to the 4 divided by x cubed is x. Just think about it. When you multiply this, negative 4x cubed, by negative 7x, do you get positive 28x to the 4? If yes, you've done it correctly. Now, what should come next? We're dividing this term by negative 4x cubed. Negative divided by negative is positive. 48 divided by 4 is 12. And x cubed divided by x cubed cancels out. So that's what we're left with. Again, multiply this, negative 4x cubed, by positive 12. Make sure you get this. We do, so we're okay. All right, so now look, the GCF is now 1, and notice a is 1. That means now we can use the big cross. We're looking for two numbers whose product is positive 12 and whose sum is negative 7. You probably have guessed them by now, right? Since they're both, since the product is positive but the sum is negative, they both need to be negative. And I think you'll agree that 4 and 3 will take care of the job, right? Negative 4 times negative 3 is positive 12. Negative 4 plus negative 3 is negative 7. So we have the right combination. Don't forget that you have to carry the negative 4x cubed. And what do you get? You get x minus 4 times x minus 3. Quick check. First times first is first. Last times last is last. Inner is negative 4x. Outer product is negative 3x. And they combine to give us negative 7x. So we're good. All right, so there's another example where the GCF was not 1 and needed to be factored out first. How about this innocent looking problem? We want the product, well, the GCF is 1, A is 1. That means we can use the big cross, right? Looking for two numbers whose product is positive 1 from here and whose sum is also positive 1, right? The coefficient of the middle term. So can you think of two numbers whose product is 1 and whose sum is 1? Well, good luck. You're going to be spending some time here, right? No can do. It's not possible. There are no two whole numbers or integers where that can happen. That doesn't mean they don't exist. They do. You're going to learn how to factor those in college algebra. But for the time being, we are not going to be able to find any integers. So we say this is prime over the set of integers. That just means you can't find nice simple numbers where this can happen. So in situations like this, we say this is a prime polynomial over the set of integers. Now, normally in this class, they're not going to require you to say that, but just in case you're interested in continuing with mathematics, that's what we would say. So this is a prime polynomial. Try this one for the road. This is our last one. Notice that we're looking, the GCF is 1, A is 1. We can use the big X or the big cross, looking for two numbers whose product is positive 8 and whose sum is positive 5, right? So, I mean, looking at the factors of 8, as you know, doesn't look too promising, because we have 2 times 4 or 1 times 8, and neither one of those are going to give us positive 5 when combining them, right? So this is another situation where you're not going to find nice integers taking care of that. So this is another example of a prime polynomial. Now, just as a gift for the road, there is a way that you can make sure this is prime, and it's a test I'm going to show you, and I recommend you do it, because the problem is when you teach people about prime polynomials, as soon as they try something for a couple of minutes, they decide, okay, it's prime. Given that the majority of the problems you're going to be doing are not prime, I want to give you this test. The test works like this. If you have a polynomial of the form ax squared plus bx plus c, go ahead and calculate this value for it. This value is called the discriminant, and it's b squared minus 4ac. So, for example, in this problem, don't worry about the variable. It can be anything. So here it's y, but it doesn't matter. So notice in this problem, a is 1, b is 5, c is 8. If you calculate the discriminant, that's what it's called, you get b squared, 5 squared, minus 4 times a, which is 1, times c, which is 8. So you get 25 minus 32, which is -7. Now, right away, you can tell from that this is not factorable. Any quadratic trinomial which is factorable, and you perform this test for, find the discriminant, this number here will be a perfect square. That means it'll be either 0 or some positive perfect square. So notice that when it's negative, you know for sure this is not going to be a perfect square. So just to show you that it does work for factorable cases, let's take a quick look at one of the factoring problems that we did, which was factorable, real quickly. Let's go back 1 second. You remember this one we did a while back. If we do a b squared minus 4ac test for this one, look, a is 1, b is 1, c is -30. So if we calculate the discriminant, which is b squared minus 4ac, we get 1 squared minus 4 times 1 times -30, right? So we get 1 plus 120, which is 121. Recognize that? That's 11 squared. So whenever a problem like this, quadratic trinomial, is factorable, that expression is going to be a perfect square. You'll understand why quite a bit later in the term, when we do quadratic expressions and equations in detail. But for the time being, just take my word for it and do the test before you give up and decide that a factoring problem is in fact prime. So that's one sure way to know that you have actually detected a real prime polynomial. All right, with that note, that should do it for this section. So make sure you practice these. These are going to take a little bit of getting used to, because you remember you're taking care of 2 requirements at once. That's more than you usually have had to worry about till now in math. So make sure that you take your time with these, practice them, master them. You're going to be encountering these a whole lot the rest of the term. So you're going to really want to be comfortable with them, and that should put you in real great shape for the rest of the term. Factoring is so fundamental that if you don't know it, the rest of the term is pretty much going to be impossible. Not just difficult, but impossible. So that should do it. So stay safe till the next video, and we'll see you then.